Hello, algebra students. So we're looking at graphing polynomials. And we talked about this a little bit in class. We're going to be graphing these, and we're going to be using that end behavior. That will help us graph the polynomial. If we know what it does when you go to the left on the x-axis, when you go far to the left, what does it do? And what does it do when you go far to the right? Well, that gets you started graphing it, and then we need to know what it does in the middle. So we didn't talk about that yet. That's what we're going to do today. Add that in, and we'll use what we look at today along with the end behavior to graph these things. So it will depend on the zeros of the polynomial. That's what's going to help us graph the middle part. So what are the zeros of a polynomial? Well, for example, find the zeros of this polynomial. What values of x make the polynomial equal 0, which means solving this, right? Finding out what are the x values that make that true, that make the polynomial 0. And the way we do that, remember we factor this. So this one we'll go ahead and factor, and we have x here and we have x here. We look for numbers that multiply to make negative 42 and add to make negative 1, and that's negative 7 and positive 6, and that's it. We've got it factored, and then we solve each of those, each binomial, that is, set it to 0 and solve it. So set the first binomial to 0, solve that, x equals 7, and set the second binomial to 0, solve that, x equals negative 6. So we have there the zeros of the polynomial. 7 and negative 6 tell us those are the values of x that make the polynomial 0. So if we had a function that was just defined as this polynomial, and we graphed that function, we know that that function will have a value of 0. That is, it will cross the x-axis at 7 and at negative 6. So over here at 7 and about here at negative 6, the function value will be 0. The function will cross the x-axis, therefore, at those points. And we know this is a parabola, right? It's a quadratic, so it's going to open up or down. This one opens up because the x squared term is positive, so we use a little bit of our knowledge of quadratics to graph it. We can also, though, use our knowledge of end behavior of any polynomial, right? And we look at that term that has the highest power of x, and it's that term, and it's an even power, and the term itself is positive, so it end behavior looks like this, right? And so it goes up there and there. As we go far to the left, it goes up, and as we go to the right, it goes up. We know it crosses the axis at these points we just found, so it must do something like this. And we've graphed it using end behavior. Okay? So I'll try to make that look a little bit better. Whoops. There, that's better. So that's our first example. Graphing a polynomial using end behavior and also using the zeros. So let's look at this idea of zeros some more and just write a polynomial given the following zeros. So this is kind of backwards, right? But we want to make sure we understand this idea. So let's write a polynomial that has these values as zeros. That is, the polynomial equals 0 when x is 2, 4, and 5. Well, each of those zeros comes from a factor. You have to have an x minus 2 in there, right, to get the 0 of 2. And you have to have an x minus 4, and you have an x minus 5. Because you will solve the binomial, right? You will do x minus 2 has to be 0. Add 2 to both sides, so x equals 2. So that is just showing that x minus 2 is going to be a factor of a polynomial that has 2 as a 0. Okay, so I'll take all those notes out of there. Okay, so there we have it. And if we write it as a function, it'll be like this. So you might say, well, that doesn't look like a polynomial. And you're right. Polynomials have terms, right? So we could multiply this out, though. And we would take x times x, and then we would take, right? And then we would do this, and we would do this, and we would have, when we got finished with that, a quadratic trinomial. Then we could take that quadratic trinomial and multiply it by the binomial in the same way, and we would get a bunch of terms. So this is a polynomial. It's in factored form. The way we have it is we call it factored form. So it is a polynomial, just in a different form. And it's okay to leave them like this for what we're doing. Okay, so if you have a question like this on a test, write a polynomial given the following zeros. If we don't tell you that you need to multiply it out and put it in standard form, you can leave it like this. Okay, let's look at the next one. Write a polynomial given these zeros. So, okay, it's to get a negative 2 as a 0, you're gonna have to have an x plus 2. Now, what about to get 0 itself as a 0? That would be x minus 0, but we can just write that. That's just x, correct? Okay. And then this looks kind of funny. We have 1 and we have 1 written twice. That means when we write it twice, we mean it comes from two different factors. You have an x minus 1, and you have another x minus 1. So that's very important. When you see that twice like that, write the factor twice. Now we won't just leave it like this. We need to simplify this a little bit. We'll put the x out front. We'll write x plus 2, and then we'll write x minus 1, that quantity squared, okay, to show that it's there twice. Okay? So let's look at the next one. X equals negative 6, 0, and 0 are the zeros. So we have x plus 6 as a factor, and again x minus 0, which is just x. And we'll usually write that the other way around. Put the x out front. It's just the more typical way of writing it. Last one. You have x plus 2 and x minus 7. Okay, so that should give us an idea of what we're doing with these. We will usually be given the polynomial and have to find the zeros, and then we will use those zeros to help us graph the function, graph the polynomial. So let's look at some of them. Graph by roots and end behavior. Let's look at this first one. First, we need to find the roots, and I'll just write them up here above. The roots are, okay, from the first one we have a root of 2, and then from the second one we have a root of negative 5. Okay, so we know those are the roots, and so we can graph those Oh, sorry, not negative 5, 5. Sorry about that. Let's fix that. Okay. Um, so we can go ahead and show, yep, there's a root there. There's a root there. Now, if we know the end behavior, we'll have it. But we don't have this in standard form. So to get end behavior, we want to look at that term that has the largest exponent, right? And we want to see, is it positive or a negative, and is the exponent even or odd? So we don't have to multiply this out. We could. If we multiplied it out, we would have all the terms, and we would have that term as well. But we can sort of take a shortcut and just think about that term with the largest exponent and what that's going to be like. And we know we're going to have this x times this x at some point, and that's going to be x squared. And so that's going to be the term with the largest exponent, right? And it's positive x and it's positive x. So it's x squared. Positive x squared. Let's just kind of write that down here. Positive x squared is that's our key term that we're looking at. It is positive, it is even, so the end behavior is just like the one we looked at a while ago. The end behavior goes up and up, and we know it crosses, so it's going to go below here, something like this, and that's it. Now in general, we have this little note here. What is the degree? We looked at this when the degree is 2. We figured that out. In general, you count the x's. That's the degree. Okay, because those x's sometime or another are going to be multiplied by each other, right? And that's going to be the term that results from that is going to be the term that has the highest power of x. It's going to show you the degree of the polynomial. Okay, so you also just have to look at those terms look at those x's for the positive and negative to figure out whether that term will be positive or negative. Of course, you have to know that as well as the degree. Okay, so let's look at this one. B. So we've got 3 x's, right? And they're all positive. So we're going to have, that is our key term. It's to the 3rd power and it's positive. So we have that end behavior in that one. Do you remember? End behavior in this case is negative infinity when you go to the left, and when you go to the right, positive infinity. So down and up. Okay, so we have to get our zeros, and using our zeros and our end behavior, we will graph this. So the zeros and I called it roots over here. That's just another word for 0. Okay, I'll go back to, well, I'll stay with roots. Okay, so the roots are, well, we've been saying zeros all along. I'm going to change that. So the notes will be more consistent that way. So there are the zeros over here. Okay, from this one, okay, we have 0. From this one, we have -2. From this one, we have 1. And so let's graph those. This just shows where it's going to cross. And boy, some of those are close together, so it won't have much time. The graph doesn't go loop very far down probably when they're that close together. but we might be surprised. We'll look at these in a minute on an actual graphing calculator and see what they look like. Because what we're doing here is a sketch. We don't know how far down this went, right? We just kind of guessed. And the same with all of these. So, we've got the zeros, we've got the end behavior. We know that as we go to the left far, it goes to negative infinity. So it's going to come down like that. It's going to cross here and it's going to go back. And it's going to cross here and it's going to go back. And then it goes to positive infinity. Okay, so we might have something like that. Okay, let's look at a couple more of these. Whoops. Let's scroll down. Okay. So we want to get our zeros. Okay, and from this x we have, that's like x minus 0, right? So we have 0. From here we have negative 2. Oh, but we've got a couple of those, right? It's very important. You have this repeated, so we're going to have a negative 2 and another negative 2. I'm going to write those a little bit differently. I think it's more useful to write them like this, one on top of the other. And then we have a 1 and we have 3. So those are the zeros, and our end behavior is we have to find the degree, right, and the sign of that first term, that term with the largest power of x. Well, how many x's do we have? 1, 2, 3, 4 of them. They're all positive. So we have this, and even exponent that's on a positive term gives us this end behavior, up and up. So let's go ahead and graph those zeros. Well, we had 0. The negative 2 is there twice, and that means it's going to bounce. Okay, we'll see what that looks like. It won't actually cross, okay, but bounces off the x-axis, we might say. We've got here, and we've got here. So, our end behavior, positive infinity, both of them, right? Up and up. So, oh, this is, wait a second, I made a mistake. 1, 2, 3, 4. There's 5. This should be negative infinity. Oh, let's fix that. Sorry about that. I missed one because this is squared, right? So that's kind of, in a way, good that I made that mistake. Not really, but that's an easy mistake to make, so it's good that we point that out. Okay, so this end behavior is wrong. Okay, so we square this binomial. So that's going to give us another x, right? So there's actually 1 x here, then there's 2 more from squaring this, and then that makes 3, then 4, then 5. 5 x's. Apologize for that. So that's odd. And so when it's odd, you have, it's odd and positive, you have this end behavior. Okay, so let's look at this. Negative infinity, and it's important to realize this is the one that bounces. Okay, this is this negative 2, 0. And so it does not cross there, but bounces and comes back down. And then it does cross at the rest of these. It crosses here, and it crosses here, and then we have Oh, I didn't finish these. I stopped myself. There's also 3, right? 1, 2, 3. One more. And then, so it goes back and crosses again, and then goes to positive infinity. Okay? So we have all the zeros. 0, -2, 1, and 3. It does bounce off the negative at -2, and then it crosses at 0, crosses again, going back down at 1, and then crosses going back up at 3, and the end behavior is that it goes on up to positive infinity as you go farther to the right. Okay, one more. Now this time I'll try to count the zeros correctly. I count the x's, that is. So let's get our zeros. Well, from this x here we have 0, but we have a couple of them. Whoops. From the next one we have 1, and then we have 3. Okay, so there's our zeros. Let's go ahead. We'll plot these, but remember it's going to bounce when it gets to that one. 1, 2, 3. There they are. And what's our end behavior? Well, we have how many x's? There's x squared, so there's 2 there. And then we're going to multiply by another one and another one. So altogether 4, right? 4 x's. So x to the 4th, and again, this one is positive because there are no negatives in there. Okay? If there's a negative, it would be negative x to the 4th. But if there were 2 negatives, of course, negative times negative is positive. Okay. So our end behavior, when you have an even, when your degree is even, and the term is positive, is this. Okay, up and up. Okay, so when we're on the left, it's up. It bounces off this. What did I leave out? One of these. I'm looking at my notes. No, this should be right. 1 and 3. Okay. Oh, it is wrong. -3. Ah, sorry guys. Let's just erase those. It's the easiest way. -3. Okay. So it's over here. You guys probably noticed that. And when is he going to notice that? That's not right. So we have -3. We have 0 where it bounces. And we have 1. Okay. And our end behavior, I did have that correct. X to the 4th. Okay. So up and up is our end behavior. So it's at negative infinity, it's up. Comes down to this one and it crosses. As you look at each of these zeros, you have to know, does it cross or bounce? Okay, it crosses at that one. And then you come to this 0 and that's where it bounces, right? And then it crosses and goes on up. Okay, so that's graphing using end behavior and the zeros. And just for fun, let's see how close these are to the actual graphs. We just guessed, right? We don't know how far. And for example, this might really come way down here, or it might even go farther. We don't know. But let's take a look. I've got these queued up in this graphing calculator. So this is the first one. Oh, I think I might. I have got a 2 out front. That's not right. How did I do that? Let me fix that. Okay, I accidentally typed a 2. I'll just fix that. It actually is like that. Okay. So, that's not too bad. This is the one we're talking about right here, okay? So, and there it is over here. Okay, so let's look at another one. Maybe I can move this over here so it won't cover it up. Now, you see we have this x times x plus 2 and times x minus 1. That's the next one, which we have down here. And there it is. And our graph is kind of close to that. Zoom in on it a little bit. So our guess wasn't too bad. This real graph comes up a little higher than ours. I made this too low, but it's reasonable looking. Got a stray mark on there I'll try to get rid of. Okay. So let's look at the others. Move this out of the way. So now we're going to look at C. And this one, oh, what happened here? This one looks quite a bit different. So it goes way down. So if you really graph it, you see it has a lot larger swings than the one we did. So I just barely went down here, and this thing goes down more, and then it crosses and goes down. And this last loop here, where I have just going down a little bit, it goes all the way down almost to -40. Okay, so that just shows we're just guessing. Sometimes we're really close, sometimes we're not. But we're actually making a reasonable sketch of the graph. It's just we didn't get the swings as far. Okay, and then let's look at the next one. And again, what we did wasn't too bad. One of this first swing goes down all the way past 10. Mine doesn't go far enough. And the next one is a really tiny swing, and mine's actually a little too much. So all in all, it's just a sketch. It gives you an idea of what the graph looks like. We're not going to try to get these more accurate than what we do using end behavior and zeros. Now, how would you do that if you wanted to? And you could do this just for fun. You could get quite a bit better just by picking a point, right in the middle here. Okay, that's like -1.5. You could plug -1.5 in for x, and calculate this, see what it is. And apparently it turns out to be a pretty big negative number way down here somewhere. And if you did that, you would get a pretty good idea. You could sketch that more accurately. But we are not going to do that. So that is graphing using zeros and end behavior. And that is all for now.